Hey seniors, so today starts our benchmark review. You guys have your benchmark 1 week from today, so let's crush it. Let's make today count and let's all push mastery. It's totally possible on this test. So the first thing we're going to look at today, we're going to remind ourselves about real life graphs. Now, this is a time and speed graph, and it's telling us about Lee working out. And so let's go ahead and just interpret this graph. Now, I see that he starts at minute 0, which makes sense. Beginning of the workout, if you haven't worked out, the minute is 0. The minute he starts running, from minutes 0 to 5, he's increasing his speed at a constant rate. And I see that because this line is slowly going up. Then I see from minute 5 to 15, Lee runs at a constant pace of 5 miles per hour. And I see that because the line flattens out. Then, from minute 15 to minute 20, he increases his speed from 5 miles an hour to 7 miles per hour. And then he runs along at 7 miles per hour from minute 20 to minute 35. Then he starts slowing down and decreases his speed at a constant rate from 7 miles an hour back to 5 miles an hour from minute 35 to minute 40. Then, from minute 40 to minute 55, he runs again at a constant speed for 15 minutes at 5 miles an hour. Lastly, at minute 55, he starts decreasing his speed at a constant rate, which makes sense because that's normally the cool down portion of people's workouts. So always think to yourself whenever you're looking at these graphs, what do these graphs mean in real life context? And cool. All right, let's move on to our next example. All right, guys, we haven't done this in a little while, doing solutions with substituting in coordinate points, but it's a similar idea. So our question, is -1, a solution to the following systems? So what I'm going to do is I'm going to take my coordinate points, which are -1 is my x value and -1 is also my y value, and plug them in to our equations. And again, it has to work on both equations for the solution to be, for the coordinate point to be a solution. So my first equation, I want -4 to equal -4 on both sides. In my second equation, I want -12 to equal -12 on both sides. So let's just start with our first one. If I have x plus 3y equals -4, I'm going to substitute in my coordinate points. So instead of x, I'm going to write -1. I keep my 3. I'm going to create a pocket in place of y. And in place of y, I'm going to add -1, and that all equals -4. Now, -1 comes down. 3 times -1 is -3 equals -4. -1 minus -3, keep change, because it's subtraction. I get -4 equals -4. So this coordinate point works for my first equation. Let's see if it works for our second equation. I'm going to write 3, pocket. -1 goes in my pocket in place of x. Plus 9, pocket. -1 in place of y equals -12. 3, I see that 3 and -1 are squished together, which means multiplication. 3 times -1 is -3. And then 9 is squished together by multiplication to -1. 9 times -1 is -9. And that equals -12. I just bring my -12 down. 3 minus 9, keep change, becomes -3 plus -9. -3 plus -9 is -12. And since it's equal on both sides, this coordinate pair is a solution. So this coordinate pair works. All right, guys, that was a short video for today. Let's go ahead and just get into practice.